On behalf of IIT Bombay Alumni Association Mumbai chapter, I welcome you to our session, Metro Marvels. Today we have with us Mr. Dilip Sinha, Director of Systems of the Metro PIU at MMRDA, who will share with us his insights about the working of metro rail systems with a special focus on Mumbai Metro. Welcome, sir. It's a pleasure to have you on.
Thank you.
Before we jump into today's topic, I would like to share a brief introduction about Mr. Sinha. He graduated from IIT Bombay in 1990 with a BTech in Electrical Engineering. He worked at TISCO, which is now Tata Steel, for 3 years, and then he joined the Indian Railways in 1993, where he spent a decade growing as an assistant engineer, divisional engineer, and then deputy engineer. After that, he moved to Delhi Metro Rail Corporation as general manager, overseeing operations of train control, signaling, telecommunications, and fare collection systems. He then served as director of systems at Kochi Metro Rail Limited before moving to his current role at MMRDA this year. Mr. Sinha has served in mainline railway for 10 years and metro rail for the last 20 years. His main areas of expertise lie in project administration of systems such as electrical, rolling stock, signaling and telecommunications, and in managing operations and maintenance. Welcome again, sir. Uh, addressing today's topic, Metro Marvels, we would like to hear from you about three main themes. One is that building a public transport network for a city like Mumbai is a massive undertaking. Projects worth thousands of crores, spanning decades, catering to lakhs of daily commuters at affordable ticket prices, all the while causing minimum disruption to the city life. How does one go about addressing this mammoth task? Secondly, apart from the Mumbai Metro, the Kochi Water Metro was started recently. It is a marvel in itself, the first water metro system in India and the first integrated water transport system of its size in Asia. As someone who has played a key role in this project, it would be great to hear from you more about it. And thirdly, we want to know more about your journey from electrical engineering at IIT Bombay to Director of Systems at MMRDA. What inspired you to join the government services, railways in particular, and how has your experience been since then? To all the viewers, we will be taking questions at the end. So if you have any questions, please feel free to post them in the comments. And without further ado, let me hand it over to you, sir.
Thank you, Megha. Let me take this opportunity first to thank Mr. Ajay Kunnath and Ms. Megha Gupta to give this opportunity to me to reconnect, I would say, to my alumni chapter, IIT Bombay alumni chapter. So, can we have that presentation now? Yeah. So, so as Megha told that right now I am working in Mumbai Metro. So Mumbai Metro today has taken a mammoth task of bringing metro to the entire city. So it's around 337 kilometers of metro they are planning. So if you could see in the diagram, the lines which are shown on the Mumbai city, it's crisscrossing the whole city, north to south, east to west. Presently, we are running around line 1, line 2A, 2B, which is around 40 kilometers is already in service. Line 1 is done on a PPP model by Reliance. Line 2A and 2B are run by MMRDA only. They have another organization, what they call as M3OCL, Maha Mumbai Metro Operation Company Limited. So that is the operating arm of MMRDA. MMRDA is the executing authority for all the over ground line or what we call an elevated line. And we have got another organization in Mumbai, what we call as MMRCL, Mumbai Metro Rail Corporation Limited. They are doing the underground line and which is going to get live by December. So this is where we are in terms of the metro expansion in Mumbai. So today, as Megha introduced, my effort would be to take you a little bit inside what is there as part of the metro, both civil and system. I will be talking more of the systems part. So next slide, please. So when we talk about a metro system, now, so what I have tried to stitch here is that how this massive project comes into picture. So as a bird's eye view, that how do we start? So the first stage would be a comprehensive transport study. So this is where we actually start. So when we are start the projection of around 25 to 30 years of the city development and what kind of transport the city would require, that is what is captured in the comprehensive transport study. And one of the key requirements as far as the metro is concerned, I mean, what we are concerned about is the what kind of traffic it would require and what are the corridors where these traffic will be required. And the important part will be the what we call as a PHPDT, like what peak hour per direction traffic. So what is the PHPDT on a particular uh, transport transport corridor? So after we are able to calculate that, and together with the forecasting of around 30 years, then we go for an alternative analysis. So alternative analysis is that what kind of a mass rapid transport system which will be used on a particular line. So there are different options. So if the PHPDT is a lying between 60,000 to 80,000, we would be going for a metro system, which is a heavy mass transit. And if it is lower, then we would be going for a light rail. Then we have got BRT, bus rapid transit, and so on. So this is the second stage where this is decided that what kind of system we will be going for. Then the third stage will be making a detailed project report. Detailed project report will come with the technologies, what kind of technologies we'll be using, and technologies would mean in terms of we can go for a AC powering or a DC powering, and things of that sort. The next stage will be drafting of customer specification, so and making the tender packages, and then we go on and onboard those contractors in the government system. We'll have to go for a tendering process, and there we'll have all the contractors. So in a project you will have a rolling stock of the train supplier. You will have we will have a supplier who will give the power systems, that overhead electrification and the receiving substation and so on. Then you will have uh, a tenderer who will be giving us the signaling and telecommunication platform screen door. Then the firefighting system, lift and escalators, and then the next stage would come design, manufacture and supply, integrated testing and commissioning. The last will be the service trial. The train has to be tested on the viaduct, and we have got agencies which validates our design and validates the commissioning. Uh, the agencies are RDSO, the Railway Design Standards Organization of Indian Railways, and safety clearance is given by Commissioner of Railway Safety. So that's the whole process by which the train would be running, and this whole process takes 3 to 4 years. So that is in brief the activities of the project. Next slide. Can, can we have next slide, please? Yeah. No, the previous one. A previous one. Okay, so what I was talking about now let's see uh, the system part. So broadly the project work is divided into civil works and system work. Civil works would be acquiring the land, putting the stations, making the viaduct, the pillars which you see on the road or on underground sections, and putting the track. And so that comes under the civil part, and the system parts are the rest part, which the trains, signaling, the communication, and so on. So I would be concentrating here now on the system part. So while designing the system part, what are the key factors? So one of the factors I already talked about was the PHPDT, peak hour per direction traffic. So based, and then what is the traffic pattern? Traffic pattern meaning that whether the trains will be running on one line or trains will be running on two lines, and they will be running in merry-go-round type. So, so that's the traffic pattern. Will decide what kind of systems we'll be putting. Then operation hours. Then typically in metros, the interstation distance is around 1 to 1.1 kilometers. Somewhere it can be higher also. Like when we are say connecting in Hyderabad, when we are connecting the airport, so we could have uh, interstation distance higher. So that allows us to have trains which can go at higher speed. So our trains here with an interstation distance of 1 to 1.1 kilometer, the average speed will come around 30 to 35 kmph and a peak speed of around 70-75 kmph. But if you have got an interstation distance of say 2 kilometers or 3 kilometers, or even in some cases 5 kilometers, then you can go for the higher speed of say 130 kilometers and so on. Then one has to then decide to meet the PHPDT, the peak traffic, that has to be met in terms of the number of trains which we are using, and the signaling. Signaling allows us the headway that what are the trains, the separation of train. So how much separation of train we can have. So based on these two parameters, we are able to decide about the headway, decide about the number of trains which are required, the kind of signaling which we want, and thereafter we also have to see a dynamic traffic requirement, whether we require to withdraw the train. See, many of the times the traffic is directional. So in the morning we have heavy traffic, in the evening we have heavy traffic, but in the day it is lull. So we have to have facilities of withdrawing the trains in the day. So so that is also has to be made part of the specification. Next slide. Then the power systems has to be decided. There are two flavors. Either we go for an overhead electrification, which you would have seen in Delhi and Mumbai, and the another one is DC also. DC is used in smaller metros, and DC is preferred in many cities because the overhead wire on aesthetically it is not accepted in many cities. So DC is a better solution. DC is little costlier. AC system is more indigenized. Some of the components of DC still has to be imported. So a call is taken between AC and DC. Then we have to connect to the grid to draw the power, and also we can have introduce solar power to have so some part of the power can be shared. I can give you an example. Kochi Metro, they have put a lot of solar. They have put it on the rooftop, like a station rooftop, and some of the areas where they got vacant land, and they are able to cater to around 40% of their power needs through solar. So that is another point of decision, that what kind of system we are going to put. Then comes the mode of operation. We can decide to have mode of operation with driver or without driver. So that will also define what kind of systems we are going for. Next one. So this is a typical track layout I'm showing here. This is one of the lines on Delhi Metro. So you can see it's around 18 kilometer of line, and you can see the stations here. And this line, the trains are moving from end to end. So you have turn back facilities at the end, and the headway is achieved between the trains when the train is moving one after another, and then when the train is turning back. So turning back is becomes very critical, because that is where the headway becomes critical. So one has to manage by turning back the train in both in the front of the station as well as the rear of the station. We have to mix it to get a good headway. Next slide. These are a few pictures of rolling stock, the trains which we are using. And this is an overhead electrification you're seeing here. So when the train arrives, normally it takes around 1 year to make a prototype train. That the train would come, and then both static and dynamic tests will be done on the trains, and thereafter testing will be done by RDSO, as I told before. So oscillation trial is done, then train is moved at a particular speed and seen that the uh, uh, whether the vibration in the train or the schedule of dimension meaning that whether train would touch the platform coping or not. So all these tests are done in details, and thereafter it is cleared, and uh, then it can be put for commercial use. Next one. Uh, Signaling system is another group which is also very important after the rolling stock. So how the whole system is getting managed. Uh, so the trains which are there on the track, they are detected. The location is detected through devices on the track called track circuit or axle counter. So once these trains are detected, then thereafter there is a computer-based interlocking system which sets the routes and authorizes train movement. Now, setting the route means that you are moving on a particular line, and then there are switches which will take the train from one line to other line. So that is the part of the work of the computer-based interlocking system, and then all these movement is automatically done. So as per the timetable, the trains will be put in the service and it will be moving on the line. Then there is an automatic train protection system which ensures that the train separation is maintained. So train separation, typically 35 to 50 meters train are separated, and if the train comes closer than that, then automatically brakes would be applied and that separation is maintained. Then there is an automatic train supervision system where all the trains are monitored in a control center. So the information about the train movement is available on a on live basis. And then there are different driving modes. The one is with a driver and supervised manual, what we call. So driver is there, and it is supervised in the sense that if he tries to move beyond his authorized location, then automatically brakes will be applied. Then there is an automatic train operation where the driving is done automatically and a limited function is done by the driver. And then we have got unattended train operation where the trains can be run without drivers. So unattended train operation recently was has been started in a limited way on one of the lines of Delhi Metro, and in Mumbai Metro also. Presently, we don't have unattended train operation, but we will be commissioning it soon. Next slide. So here there are some pictures of the signals. You can see in the first of the pictures, you can see the signals on the track. Then there is a data communication system. So there are antennas all along the track side and as well as on the train. So train is communicating with the track side on a continuous basis. There is a point machine. What I was talking about, that setting of routes. So these are point machine which switches the track from one movement to another movement, and so the train can go straight here. If the train is coming from far, it can go straight or it can go to the diverted track. So this is getting decided by the interlocking system based on what kind of movement we want. Another emergency stop plunger we are showing. This is also part of the signaling system where passengers can intervene and break a train, stop a train in case of any emergency. Next slide. All the equipment of the signaling systems is kept at the station in a common room. So these are the interlocking system, the different modules you are seeing here. Next slide. A little bit about how this train separation is being managed. So if you can see in this schematics, so there are two trains, train A and B are shown here. So the train B, it knows its location based on the odometry, and there are balises all along the track. So the balises are fixed geographical position. So an antenna is there underslung on one of the coaches, So the train knows, based on these balances as well as the odometry, the exact location where it is on this network. And this particular information, this train P sends it to the trackside and trackside equipment. So this is what is shown here. In 2, the onboard radio on train B transmits its position to the CBTC trackside equipment. CBTC is communication-based train control. This is one of the signaling system which is getting used in India. Now, based on this information, the trackside CBTC calculates the point to be protected by the tail of train B. So train B is continuously moving, and its location is now known. So train A can move up to the tail of the train B. So that information is continuously available to the trackside, and the trackside passes it to the onboard of train A, and that becomes a distance to go for train A, and train A knows its own characteristic, that what is the maximum speed at which it can go, and based on that it gives a maximum speed at which the train A can drive. So this is how continuously the train A and train B will be following each other. Next slide. Now the train supervision, now all the information of the trains on the site is mimicked on a dashboard. So this is available in the operation control center. You can see here that the network has been mimicked here in lines, and the trains are depicted on the lines here. So one can see the movement of the trains on the line. So decisions can be made: how many trains are there, when to remove a train, when to insert a train. So all these decisions are taken from the OCC. Next slide. This is a view of an operation control center. So same view which you saw in the previous slide. This is depicted on a large video screen, and typically CCTVs are also available. So one would know that what kind of crowd is there at different stations, and critical location, the information is available. This CCTV is also important when you are running unattended train operation. So whatever the driver is doing in case of emergency, lookout, or the action which he has to take. So those information are taken from the train and depicted here. So so this CCTV information helps in doing the unattended train operation. Next slide. This is one of our stations in Mumbai Metro, where the platform screen door. Platform screen door is also a very important component. The kind of traffic we have in Mumbai, and especially during the rush hour, the surging traffic. So platform screen door is made available, and this opens and closes in consonance with the doors of the train, so that we don't have any accidental falling of passengers on the train, on the track. Next slide. There are a lot of information is made available to the passengers. If you see the kind of passengers we handle at the station, so we normally have 1 or 2 persons at the station. So the information, sharing of information to the passengers continuously is very important. So part of that is this clock, the time information. Then we internally for operation, we have a continuous communication between the operation control center to the driver as well as the station controller. That is done through a tetra system. So these are one of the photographs you're seeing is of a tetra tower used for the communication. Then CCTV is all made available at different places. The passenger information display system, which if you go to the station, this information of the next train is available, and at the platform you will see and how much time the trains are coming. So these are live information. As I told you that all the trains are getting tracked continuously from the OCC. So the information of the train is available centrally. So that is fed in this platform information display system, and one would be able to know when the next train is going to arrive. Also, there are information, other information which is useful is also displayed. Like for example, how much occupancy is in a particular coach. So people can realign on the platform to go to a coach which is less crowded. And so this is done by capturing the weight of the train, weight of the coaches, and then transferring it to the track side. Passenger announcement system is another part. Here, there are some other facilities which I'm showing it here. This is an escalator. You will see escalators at all the stations. So lifts and escalators are provided so as to cater to differently challenged people. Next. This is again a picture of a lift being commissioned. Next slide, please. We have a firefighting system inside the station. So there's a pump room there, and water bodies is there, water tank is there, and firefighting system will be there in the full station. Diesel generator set is also provided for emergency power. Next slide. Again, this is a picture of a fire hydrant cabinet, a manual call point, fire alarm, control panel. So these are part of the station equipment. If you happen to visit a station, these you will find it at the station platform as well. Next slide. The fare collection system in Mumbai Metro is an important component. Here, national common mobility card has been used. So the card which is getting used here, so it not only works in metro, but in our metro, in the sense MMRDA metro, but also works in line 1, which is Reliance, run by Reliance. And these card can be used for retail also. And so this is being done by this is being issued by State Bank here. And this is part of the Government of India project, where all the cards or all the systems has to come on one platform, so that one can use the cards in any metro. So Mumbai Metro is forerunner in this, and as the other metros would come up with this NCMC, so these cards will be used there also. Delhi Metro is also very shortly will be coming in full-fledged. They have already pilot project is already running, so they will be getting full-fledged in that. So these cards, the commuters who are using the card here, when they go to Delhi, they can use the same card for availing facility in Delhi Metro. So here you are seeing the ticket office machine and excess fare office. Excess fare office is, you'll see this by the side of the gate. If somebody goes little more than the stations what he has to take the ticket for, so he has to pay that excess fare. Next slide. Then these are ticket vending machine. So one can get the cards here also, as well as one can you can load the cards here, and as well as get the QR ticket issue. Next slide. These are the pictures of the barrier gates in our metro station. Yeah, we can play that video now. Just a station walkthrough. Another metro scheme which was done by in Kochi, what we named as Water Metro. So, Water Metro was a very interesting concept, and now it has started working in Kochi. So it is nothing but a ferry running ferries with a timetable and the kind of safety and comfort which is there in the metro system. Presently, around five boats are running with around ridership of 5,000, and it is connecting two islands. So Kochi, if some people know, is around it's kind of an archipelago, and 10 islands are there where a lot of people are residing, and they come for daily work to the mainland. And these boats are uh, giving them a facility, a seamless connectivity to the mainland. I'll give you one video is there which gives you a very good idea of that water metro. This was made during inauguration by Honorable PM. Can we have that verified?
Ten years back, traveling in a metro rail through Kochi city was just a dream. Today, it's a reality. Today, let me present the dawn of yet another dream accomplished by Kochi Metro Rail. Yes, the wait is finally over. We have Kochi's own water metro.
കൈവീടിലൊട്ടും ആണിയെത്തും മുടങ്ങില്ല വെടിത്തടിക്കിടി പോലി ഹൃദയതാളം
The Kochi Water Metro stations are designed with the state-of-the-art technology in ticketing and boarding. The jetties have floating pontoons with automatic docking system technology. Disconnected by road and other permanent routes, these islets stay detached from the commercial mainland. Now Water Metro merges the archipelago of these islands into one mainland. Connecting 38 terminals across 10 islands and mainlands over 76 route kilometers, the Kochi Water Metro is expected to transport 34,000 passengers every day.
So how do I feel being inside the Kochi Water Metro? It's absolutely nice, really. It's wide, it's spacious, the colors are very soothing, and it's an air-conditioned space. There is enough space for everybody to sit, and of course, if there is a crowd, you can stand as well. The windows are really large, so you get to enjoy the view as well. But the most important thing is they have paid attention to safety, so you have life jackets right under the seats. It's the most luxurious yet economical and comfortable boat ride in Kochi now. The most amazing thing is that the integrated ticketing system enables seamless travel through Water Metro, Metro Rail, feeder buses, feeder auto, all in one ticket.
The motto is to preserve this beautiful natural environment while increasing connectivity. The endeavor here was to cut carbon emissions by using clean and sustainable energy sources. The boat here is run on electrical energy. Cochin Water Metro is an initiative under Make in India. This is a concept that could be applied all across the world, especially for nations that are looking for an alternative solution in transportation.
Yeah, so I'm done, Megha. Over to you.
Thank you, sir. This was a very informative, inspiring, and relevant presentation. We take trains for granted, but there is just so much going on in the background to make these systems function smoothly, and it was so good to hear about these. I have a few questions for you. Uh, you have led metro rail projects in three cities, Delhi, Kochi, and now Mumbai. What similarities and differences did you observe while working in these projects?
Uh, Metro technology is same technically is similar in all the places. So, so the technology is also similar, as well as the expectation of the passengers, the commuters. What I found was exactly the same. So I would say that there's not much difference. Only the difference doing the project is about the land acquisition. Like in a like in a land scarce place in Mumbai, so that becomes a big challenge. Compared it with Delhi, where there are a lot of government lands, so it's not a big challenge as that. So that is the basic difference. Otherwise, I find it more or less same only.
Got it. So, what is the one skill which has helped you grow, thrive, and stand out in such large organizations?
Yeah, so the I would say that the learning that it's always about people. So keeping people at the center of the things, our stakeholders. So stakeholders are the public at large, the government, and our employees. So keeping that in the center, the decisions have to be made. So that is how one can traverse these kind of projects and these kind of government working.
That makes sense. I agree. And given the large focus on infrastructure development, what is your vision for India and India's metro cities in the next 10 years?
See, the comprehensive transport study which I referred was done in Mumbai, done in 2021. That showed that in the last 10 years, the share of public transport has reduced from 78%, 75 to 78% to around 65%, and so that is not good for a vertically growing city like Mumbai. So one of the key vision for the cities is to have the public transport back. Like say for the city of Mumbai, we should have back to 75%, and that is where this mega project of bringing around 400 kilometers of metro the government is doing. So that is one important aspect. Then how to have maximum utilization of these public transport. So that is where the seamless connectivity is important. Connectivity, last mile and first mile connectivity. Then integration with intermediate public transport like taxis and autos. The third item is which is important as far as I see is make in India. Now, government has taken a lot of initiative in standardizing the different systems in metro so that the volumes come and people are able to have they see the volume and they put the ecosystem is made for more make in India. Now in last 10 years there are very good stories which has happened. Like we have Alstom India who have set up two factory. They have got two rolling stock factories, and they have got roughly 5,000 engineers here in India, and they are now also exporting. So it's going. The trains manufactured in India from Alstom factory is going to Melbourne in Australia. So with these standardization, government initiative, and the support of public, private sector and public sector, this Make in India is happening. So that is another dream that it happens. This whole thing all deepens further.
I completely agree with you. Uh, this will be critical for India's growth story. Uh, Coming back to your personal journey, would you like to share any memorable stories from your time in India?
I was living in Hostel 7, Lady of the Lake, and that too, the wing which was facing the lake. So it was a very serene and calm and pastoral life. And recently, my 25 years reunion, when I went there, so I the whole thing was changed. Like, the lot of hustle bustle on the roads. So it's very, very, very different IT Bombay I saw. So looked like I was transported from a kind of a village kasbah to a city center. So our time was quite cool. One of the incident I remember, while I was in third year or fourth year, in the fourth year first semester, we had a work visit to Siemens,
Mhm.
and then the workshop manager there was showing us different devices and instruments there, and we some of us we didn't recognize an induction motor also. So he
Oh,
was very very he was very confused that, I mean, after some time you're going to come out as an engineer and you don't recognize things. So then we came back. Then some of us talked to our HOD. Mr. Agashe used to be our HOD at that time. So he told us that Siemens says that you are no good engineer. What kind of electrical engineer you are? So Mr. Agashe cooled us, caution, always he's cooled us. Says that no, you have learned the basics, and you'll pick up all this in 6 months. So so he was the guy who used to calm us. In our times there was one Mr. Professor Kamath who used to teach us electrical networks, and he would give very innovative problems. So his problems were all new. I mean, you'll never find anywhere. So he had a knack for that, and taking his exams was dreadful. So so
okay.
so when this also, Mr. Agassi had a very good answer to that. Once he said that, I also has taken one of his tests, and very cheekily he said that I will not tell you how many marks I got. So so these
Would-
are the very good and sweet memories I have.
Did you get a good grade in his test? In his test?
So like Mr. Agassi, I will tell you, I will not share that to you.
Sure. So, what advice would you give to young engineers aspiring to join government services and to contribute to India's growth story?
So here, see, I will not hazard a guess here, and uh, actually, I feel that the young generations have got the wherewithal to take these kind of decisions much better than what we have taken, and the younger generations are always smarter than the older generation. That is how I feel. Coming to government service, they give a bigger canvas to work, but then there could be frustrations along the way, because sometimes you may feel that you're not getting the right credit, maybe because of the multiple stakeholders, and kind of a transferable job, and you don't get to make a lot of money also in government job. That also can be a disincentive to a lot of people. And but the positive thing is that sometimes you will feel that you have touched a lot of people's lives, so, and then it feels good at times. So that is how it is.
Hmm. So, thank you, sir. I've learned so much, and I'm sure the viewers feel the same. Thank you again for taking out the time for this event. Uh, and to all the viewers, thank you all for being with us. And I hope you have a great weekend. Thank you.
Thank you. Thank you.